Hello, Dr. Ko. In this video, I'm going to explain homework 3, mass balance. The problem statement states that flow Q1 enters tank 1 with cross-sectional area of 1 meter squared, and tank 1 is connected to another tank, tank 2, with cross-sectional area 1.5 meters squared. So to begin this problem, before I state the rest of the problem, I will draw the two tanks and how they are connected. So here is tank 1, and it's connected to tank 2, and tank 2 is open to the environment. And so flow 1 goes into tank 1, and then the flow from tank 1 to tank 2, Q12, and the flow from tank 2 to the environment is Q2. And so a few other things you need to consider is that the height of the fluid in each tank can be just labeled as H1 for tank 1 and H2 for tank 2. Now that we have these defined, another thing we need to consider is that this has a cross-sectional area A1, this has a cross-sectional area A2. And this is given in the problem statement as 1 meter squared. And the cross-sectional area of the tank 1 connected to tank 2 could say is 1.5 meters squared. Okay, and so we now are also given in the problem statement that the flows can be expressed. The flow between tank 1 to tank 2 can be expressed as Q12 0.5 square root of H1 minus H2, while flow 2 is 0.25 square root of H2. And from this we see that Q2 is only dependent on tank 2, and this flow Q12 is dependent on tanks 1 and 2. Okay, and these are simply constants right here, and can be written as alpha 1 and alpha 2. And so a relationship between the two different flows is written as Q12 over Q2 is equal to, just as I said, the constants alpha 1 square root of H1 minus H2 over alpha 2 square root of H1, square root of H2. And from this we could replace that with the actual constants that we have. Okay, and so now that we have the relationship between these two flows, we can derive the differential equations for the change in height of each tank. And so that will simply be dH1 dt, the change in height over time for tank 1 will be Q1 minus Q12 over A1, while tank 2 will have a differential change in height over time as Q12 minus Q2 over A2. So right here we have our two differential equations. These two differential equations represent the change in height over time for the two tanks with the fluid flow scenarios described. And from here we can take different values and write some Python code to solve